Okay, moving on to exact values. So sometimes if we don't want to be using a calculator, there is exact values that we can definitely know. So for instance, what is exactly sine of 30 degrees or cos of 60 and things like that. Okay, so they stem from different types of triangles. So if we look at this first one, okay, so what we have is we have an equilateral triangle, all sides are 2, and we basically halved it. Okay, so in an equilateral triangle, if all sides are the same size, then that means that all angles must be 60 degrees. Okay, so what we're going to do is we are going to, first of all, figure out the missing side, which is your vertical one here, using a wee bit of Pythagoras, and then we're going to talk about how that's going to help us get these exact values. So if we've got a right angle triangle there, we're going to figure out this, it's just called A. So I'll put it down here. So A squared is going to be C squared, take away B squared. 2 squared, take away 1 squared, which is obviously 3. So A must be root 3. Okay, so how is that important? So what we can do is we can use SOHCAHTOA to basically figure out these things called exact values, okay? And then we're going to, that's basically what's going to have to go in this table below. So if we think back to SOHCAHTOA, okay, using our 3 ratios. So I'm going to start with the 30 degrees. So sine of 30, remember, will be opposite over hypotenuse. So I'm going to replace this now by my root 3. Okay, so it's opposite over hypotenuse. So opposite of the 30 is that 1. And then the hypotenuse is 2. So sine of 30 is exactly a half. Do the same with cos of 30. Remember, cos is adjacent over hypotenuse. So adjacent is root 3 and hypotenuse is 2. And then we do the same with the 60. So sine 60. So sine, again, we're going from the 60 this time. So we're going to opposite, which is root 3 over 2. Now you can see that's the opposite of cos of 30. So then cos of 60, it must be a half, right? It's the opposite of sine 30. You can obviously check. 60 is there, adjacent is 1, and that's 2. So we're going to be using, I'm just put them up here. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And obviously, I need to do tan as well. I forgot about tan. That is not tan. Opposite over adjacent. Okay, let's do tan. So tan 30. So tan is opposite of 30, which is 1. And then the adjacent is root 3. And then tan of 60. So opposite of 60 is root 3. And then you can see that the opposite is 1. So root 3 over 1, we would just write that as root 3. Okay, so those are our first law of exact values. Now the second law, we do the exact same thing, but this time basically what we start with is we start with an equilateral triangle. So all sides are 45. All angles are 45. And these sides are 1. We're going to use Pythagoras again to work out this side here. That's not A, that's going to be C. Hypotenuse. So A squared plus B squared, which is 2. So it's root 2. So we're going to do the exact same thing as before, a bit easier this time, well shorter because we've only got 45. So we're going to do sine of 45. So sine, pick this one for instance, is going to be, it's opposite over hypotenuse, just like what we just did. So 1 over root 2. Cos of 45. Again, adjacent is 1 as well. So 1 over root 2. And then tan 45. So opposite over adjacent, 1 over 1, which is just going to be 1. Now you have a choice basically, okay? You need to know all these exact values off by heart. So people either choose to remember the triangles, so they remember what they look like visually, and then what you would do is you would calculate the one that you're looking for the exact same way as I've done using SOHCAHTOA, or you can memorise them like we have in this table here, okay? So basically I have calculated all these. I'm going to put them in where they should be. And then obviously your aim is to memorise them. So if we go with the sine, so sine of 30 is a half. Now the way that I memorise it is, I always remember sine of 30 is a half. So like, right, the opposite of that one is the 60. So that means cos of 60 is a half. Okay, sine of 60 is root 3 over 2. Which means that that one must be root 3 over 2. So that's messy. 45, they were both the same. They were both 1 over root 2. Okay, tan along the bottom. So tan of 45 is 1. I know that they both involve root 3, and I think, right, the biggest one is 60, so that's the root 3. And that's 1 over root 3. Okay, 0 and 90 come from your graphs, remember, okay? Your sine graph and your cos graph are important, what they look like, okay? So we cannot forget about them. So any point you need to, you just draw a wee quick sketch. I'm going to be using these just now anyway. I'm going to draw them over here. So sine graph. That is a mess. Cos graph, I'll just chuck down here. So key values, remember, are that's obviously 90 there, that's 270, 180 is in the middle, and then that one, however, cuts at 180, 360, and 0. Okay, so therefore, sine of 0 is 0. Cos of 0, however, is 1. Tan of 0. Now, tan's a funny graph, obviously. So you've got your full tan wave going through there at 180. Remember, it doesn't reach certain values, so it doesn't reach 90, and it doesn't reach 270. So we'll draw that. They're actually called asymptotes. So that just touches the 90 like so, goes to 0 there, it would come down, and then same with that one on that side. And that's going to be it at 360. So tan of 0 is 0. Cos of 90, looking at your graph, is obviously 1, because it goes up to its maximum then. Cos of 90 is 0. So sine of 90 is 1. Cos of 90, however, is 0. It's at the graph. And tan of 90. So that's where it doesn't work, right? Not applicable. There's no value for there. So we tend to write any. Not applicable. Okay, you can't get tan of 90. It is impossible. Now, why are these important? So we need to know these off by heart. So if I asked you what is sine of 45, you say it's 1 over root 2. Okay, you need to know that. You're going to be using these to sub in to get values. What we also need to be able to do is use them to figure out other exact values, okay? So if you know your sine of 30, 45, 60, and same with cos and tan, you can use these basically to figure out other ones. We also need to know what they are with respect to pi. So remember, pi is 180. So therefore, 30 degrees is pi over 6, 45 is pi over 4, and 60 is pi over 3. And 90 is obviously pi over 2. So we're going to use these to figure out other exact values. Now the key is, okay, because of the nature of sine and cos and tan, you always get two answers, okay? You know this from trig equations from before. So basically your exact value is the same as one of these, whatever we're looking at, or it's the negative of it. Okay, that's all you need to know. So all you're asking yourself for all these questions is it the same as the exact value? Or is it the negative? So is it the same as sine of 30, which is a half, or is it negative a half? That is basically what you're asking yourself for all these questions. And the best way, in my opinion, to do it is just think about the graph. So if we're looking at sine of 150, now the key is to think, right, what is the exact value that's associated with 150? What could we use? So thinking about, we've got this quadrant up here. Okay, you've got your 0, your 180, and your 360. Those are your kind of key values we're going to be thinking about. So it's like, what exact value could we use involving 0, 180, and 360 to make the one that's there? So this one here, for instance, 150, we're going to use 30. Okay, because it would be 180 minus 30. So our question is this sine 30 or negative sine 30? That is the question that we need to figure out. Okay, so the exact value related to 150 is 30 degrees. You think about before doing your cast diagram, you do 180 minus 30, and that's where your 150 would come from. We need to figure out, is it the same or is it the negative? So the best way to do it is literally just sketch a graph, and I really do mean a sketch. Okay, think about where is 150. Okay, that's 0, that's 360. So 150 on the graph would be like there. Now you can see that that is positive. Okay, it's above the x-axis. So, oops. So it's positive, sine is positive at that point, basically, if you think about your quadrants. So therefore, it's not the same as a negative. It is sine of 30, which is a half. It's all you need to know. So if they ask you a value that's not your exact one, but it's related to it, you just need to know, is it the same or is it the negative of it? Okay, tan of 315. Now this one's obvious, it must be 45. It's the only one that ends in a 5. So our question is this the same as tan of 45? Or negative tan of 45. That is what you need to know. We're going to draw a graph. Tan graph I know is not the easiest to draw, but it's just basically figuring out, is it positive or negative? So draw your 180 first, which is there. Put my asymptotes in. I'm touching, but that's there and that's there. Okay, remember these are at 90 and 270. That's 360 there. We're looking at where on the curve is 315. Now on the curve, it must be here. Between the 270 and 360, so it must be like there. Which is negative, right? It's below the x-axis. So it's negative. So therefore, it's the same as negative tan of 45. What's tan of 45? 1 over root 2. So negative 1 over root 2. Okay, cos of 7 pi over 6. Now, for me, I think it's always easier to change into degrees. So 7 pi over 6, well, best way to do it is pi over 6 is 30. So 7 pi over 6 must be 7 times that, which is 210. Okay, so we're going to change that first. So cos of 210. We again are trying to figure out what is the exact value we would use to get this. So we're going from either 0, 180 or 360, remember? So it must be 30 because it's 180 plus your 30. So we're saying, right, is it the same as cos of 30 or negative cos of 30? I'll put them in on these ones as well. So it's always using 0, 180 or 360. Now your teacher might do this in a slightly different way, so obviously you can just ignore me if they think their way makes more sense. Right, so cos graph looks like this. I'm saying where is 210? So I'm like, right, what's my key values? I know that's 90 and that's 70, 270. So 210 must be about here. Which is negative. Okay, between the 0 and the 180. So it is the same as negative. And cos of 30 is negative root 3 over 2. Last one, sine of 30. Right, sine of minus 30. So we can't think about exact values, but what we can just think also is, just think about your graph. It obviously involves 30, right? So it must be either sine 30 or negative sine 30. If you think about your sine graph, looks like this. Okay, if we take that back, because we're going into the negatives, it's going to be like that, if it was repeating. Negative 30 must be like there. So therefore, it's the same as the negative, so it's the same as negative a half.